What if you could build an intelligent assistant that knows everything about a specific subject? Not just general knowledge, but deep, specific details about your project, your company's documentation, or some niche technology. Large language models like ChatGPT are powerful, but they don't know everything, especially about specialized or brand new topics. To make them truly useful, we need to give them the right information at the right time. One of the ways to achieve that is via a technique called Retrieval-Augmented Generation, or RAG. Another is by adding tools to your agents. Today, I'm going to show you how to build from scratch a powerful RAG-based assistant with tool calling capabilities. We will teach it about the Apache Camel framework, and we will do it using an amazing stack of tools. To do that, we are gonna use LangFlow for visually building our agent, Apache Camel itself for data ingestion, and a powerful new system called Wanaku MCP router. The Wanaku MCP router is an integration service designed to securely connect AI agents with various enterprise systems and cloud services. It might sound complex, but by the end of this video, you will see how these pieces fit together to create a seamless and powerful pipeline for context-aware AI. Let's get started. Before we build our assistant, we need to set up the system for ingesting the data that will be used by our agent. The first tool that we need is a fantastic one called Ollama. Ollama makes it incredibly simple to download and run powerful open source language models right on your machine completely for free. Just head over to ollama.com and download the application for your operating system, whether it's macOS, Windows, or Linux. Ollama will serve the embedding model for our project. This type of model transforms complex data like words, sentences, or images into a set of numbers called a vector. This process is called embedding, and it converts things that aren't numbers into a numerical format that a computer can understand and work with efficiently. Its job is to read all our documentation and turn it into a numerical format that the AI can search through. We use a great model for this purpose called Nomic Embed Text. You can use the Ollama CLI to pull and install this model. In this demo, we will use a purpose-built tool created using Apache Camel. This system consumes information, in this case taken from the Camel components dataset, and uses the Camel AI features to break that information in smaller pieces and store it in a special vector database that our AI agent can search through. Then we interact with that system using the Camel Data Loader CLI, which serves as the front end for this system. To install the CLI, you can start by downloading and unzipping the tools folder. Then uses a terminal to navigate inside and run the help command to make sure it's set up correctly. Okay, our data loader CLI is verified and ready. But before we can use it, we need to start the backend system it will send the data to. This system includes our vector database, which will act as the long-term memory for our AI assistant. Thankfully, this is incredibly easy. The project comes with a Docker Compose file that lets us launch everything with a single command. So, our backend is running and waiting. Now it's time to get the raw material, our expert knowledge on Apache Camel. For this, we will be using a prepackaged dataset of the Camel documentation from Rugging Face. This isn't just some random web script. It is a curated dataset focused specifically on Camel components, which will give our assistant the deep, accurate knowledge we are looking for. So first, install the Hugging Face CLI using pip, and then run the download command to fetch the specific dataset. This will create a new folder and save the files locally. Okay, so this is the moment we have been building towards. Our backend services are running, our high quality Camel dataset is downloaded, and our data loader CLI is ready. So now it's time to put all of this together and load our knowledge base. Start by running the consume dataset command. You need to provide the full path to the components directory that you have just downloaded. So let's run it. You can now see the loader going to work. It is reading all those documentation files, processing the text, using our local nomic embedded text model to turn them into vectors, and loading them into our database. This process might take a minute or two. We can use the command cur to send a quick request to the database, asking it to show us a couple of records it's holding, and we can pipe that output to the tool called jkey just to make the JSON response nice and readable. And as we can see from that output, the data was loaded. We can see, for instance, a status OK, and most importantly, we can see that we have a points array containing the data. If you look inside the text segment, you can see the actual text from the Apache Camel documentation. Okay, let's take a breath and recap. In the first part of our journey, we have successfully set up a complete local RAG environment. We have our AI models, a vector database, and we have just loaded it with specialized expert-level knowledge about Camel. But this only provides additional knowledge to the system. How can we have our agent interact with the world and do things like search on the internet or execute code? How can we actually add capabilities to an agent? We need tools. And this is precisely the problem that the Model Context Protocol, or MCP, was designed to solve. And moreover, how can we exchange data with existing systems, ensuring that access to them is done in a way that is safe and reliable? And for that, we need some kind of bridge or router, a standardized, intelligent front door for other sources of knowledge and capabilities. And that is what Wanaku does. Think of Wanaku as the smart router that exposes our knowledge through that standard MCP plug. It acts as the final, crucial link between our AI application and our data. So in this next major part of the video, we are going to get Wanaku up and running. And this will complete our pipeline and allow us to finally build our interactive assistant. Let's dive into part 2. Just like our database, Wanaku is defined in a compose file for this demo. So we can launch it with a single command. Use the podman compose command to launch the system. This will start with the Wanaku router service in background, and after a short while, the system should be ready to receive requests. But right now, it's like a pristine empty toolbox. It's running, but it doesn't have any tools or resources inside it yet. Let's fix that. A tool in Wanaku is a specific capability we want to grant to our AI agent. This could be anything, searching a database, calling an API, or even searching the internet. Let's start by giving our assistant the ability to browse the web by adding a DuckDuckGo search tool. The project includes a handy Wanaku command line application to make this easy. We will run the Wanaku tools add commands and give it a few details, like the name for the tool, a description of what it does so that the AI knows when to use it, and the tool's type and address. But now, how do we know it worked? First, we can ask the command line to list the available tools. And by running it, you can see DuckDuckGo search right there in the list. But even better, Wanaku has a web interface, and you can also use it to check if the tool has been added. Okay, a web search tool is great for general knowledge, but we want our assistant to be an expert on Apache Camel. For that, we need another, even more specialized set of tools. The demo includes another service, a Camel Catalog MCP server. Think of this as a micro expert. It is one and only job is to answer super specific questions about Camel components like their dependencies or configuration options. So first, let's bring that expert online. Again, we will use Podman Compose, this time pointing to the file in the MCP service directory. Now, we will use another Wanaku's feature, the MCP forwarding feature. Forwarding allows Wanaku to act as a proxy. We can register the Camel Catalog server with Wanaku, then Wanaku will automatically discover and expose all of its tools and resources, making them available through the central gateway. It's like a smart receptionist who knows exactly which expert to transfer your call to. And look at that. Not only do we have our DuckDuckGo search tool, but we now also have a whole suite of new remote tools. Get information about component, get dependency, and many more. Wanaku has reached out to the Camel Catalog server and made all of its capabilities available. And, of course, if we refresh the UI, we see them all here too. Our entire backend is now complete and configured. In the final part of this video, we will step into LangFlow, the visual AI builder, and with just a few clicks, connect to Wanaku to build and chat with our new Apache Camel assistant. The finish line is in sight. Let's do it. We have built a powerful, intelligent backend with database full of knowledge and a set of specialized tools all managed by Wanaku. Now we need the cockpit, the user interface where you can build, manage, and interact with our AI assistant. And for that, we are going to use LangFlow. LangFlow is an amazing visual platform that lets you build sophisticated AI applications by dragging and dropping components onto a canvas. Let's get started. Just like our other services, we will launch LangFlow using its Docker Compose file. Run a command and the LangFlow service will start up in the background. After a while, you can go open the browser and go to the local host on the port 7860. The first time you open it, you'll be greeted with a welcome screen. Let's click on the button to create our first workflow and then select LangFlow to get started on a fresh canvas. We could build our entire agent from scratch by dragging components onto this canvas, but to speed things up, we are going to use a pre-built agent workflow that is included with the project file. First, let's upload it. Click on the upload button near the top of the screen and select the Camel Assistant JSON file from the LangFlow directory in our project. And there it is. This graph is the brain of our assistant. Each node represents a component like our language model, our vector database, our toolset, and the line shows how data flows between them. Now, we just need to configure it to talk to the backend services we have running. First, let's set up some global variables. This is where we will put our API keys and other configurations that we can reuse across the application. Go to Settings, then Global Variables. First, a quadrant URL variable is created to point to the vector database's location. Second, an Ollama base URL variable is added to connect to the local large language model with the important instruction to apply this variable specifically to the Ollama base URL fields. Finally, a Google Gemini API key is added as a credential, ensuring it is correctly applied to the Google API fields. The final piece of the configuration puzzle is to explicitly define the Wanaku server so that LangFlow knows how to communicate with it directly. This is done in a separate settings menu for MCP servers. There, a new MCP server is added with the descriptive name Wanaku MCP router and the address of the server sent events URL. This specific URL establishes a persistent communication channel, allowing the LangFlow container to receive the real-time updates and messages from the Wanaku container. With the global settings defined, the focus shifts to the workflow canvas itself, where the individual components are wired together. This phase involves linking the abstract components in the visual editor to the concrete services configured in the previous step. The MCP tools components is connected to the powerful routing capabilities of Wanaku by simply selecting the Wanaku MCP router from a drop-down menu in its settings. Similarly, the quadrant component is linked to the vector database, not by re-entering the address, but by efficiently referring to the quadrant URL variable created earlier. And similarly, we ensure that the agent component is using the Gemini API key and is configured to use a model with function calling capabilities such as Gemini 2.5 Flash. Alright, the time has come. Everything is configured. The data is loaded, the tools are ready, and our agent is assembled. Let's test it out. Click on the playground icon on the top right corner. Let's start with a question that requires its internal knowledge, the documentation we loaded into Quadrant. Perfect. It correctly found the answer in the vector database. Now, let's see if it can use a tool. Let's ask it something it wouldn't know, forcing it to use the DuckDuckGo search tool. And look at that. It clearly states it used the search tool and gives us a summary. This is reg with tools in action. For the final test, let's ask a question that requires one of the forward tools from the Camel catalog expert. Incredible! It correctly identified the need for a specific tool, queried through Wanaku's forward, and gave us the precise URL. Our system is working perfectly. And there you have it. From a set of separate services to a fully functional, tool-enabled, context-aware AI assistant. Thank you so much for following along. Don't be afraid to experiment, ask questions, try adding your own tools and see what you can build. If you found this video helpful, please hit that like button. Subscribe for more tutorials and let me know in the comments what you'd like to build next. Happy coding!